Welcome to another episode of Off the Syllabus, the podcast where we go beyond the classroom and into the real world of careers, challenges, and choices that shape our future. Today's guest is a true builder of futures, literally, in every sense of the word. Dr. Pat Rajeev is a senior lecturer in civil engineering and construction at Swinburne University of Technology. He's not just an academic, he's a global researcher who's worked across Sri Lanka, Italy, Netherlands, and Australia on some of the most critical topics engineering today: earthquake-resistant design, infrastructure resilience, smart monitoring systems, and failure prevention. From deep research funded by governments and EU to guiding the next generation of engineers, Dr. Rajeev brings a powerful mix of technical expertise and human-centered insight. In this episode, we explore why resilience is the key word for 21st century engineers, how civil engineering is evolving with technology and global demand, and how students can choose pathways that lead to impact, innovation, and long-term value. If you're someone who wants to design, build, and contribute to a more sustainable and secure future, this episode is your blueprint. Let's go off the syllabus with Dr. Pat Rajeev. Resilience by design, building smarter futures. Hello and welcome, Dr. Rajeev. So, in today's conversation, we will have a conversation in 3 stages. First one, let's discuss some fun stuff, and then let's deep dive into the lessons, your experiences, and the third and the most important segment of the discussion, we will focus on how we can help somebody who is looking at a future in engineering, right? So going into the first segment, rapid fire. What's the coolest structure you've ever seen and why?
So there are many, but if you ask one, then I would like to go with the Colosseum in Rome, and that shows the marvelous in civil engineering construction in the ancient time, and shows the power of Romans and how they can build a massive structure still standing after 2000 years, and the construction methods, and still it teaches so many different things which we couldn't understand how they have done it up to now. So that's the one I appreciate and always admire, and the structure still has elegant and elegant features, and also is standing as a signature for Rome and Italy.
If you weren't an engineer, what would you be doing?
First of all, I think I'm not a full-fledged engineer.
Okay.
I'm an educator in the engineering field.
Okay.
So I always want to be a professor when I was small little, and I always dreamed to be continuously studying and improve my career. So if not engineering, I probably be a professor in physics. That's what I could think, and I can't go beyond that, and I just be on that circle and trying to explore things and innovate things and understand things. That's my passion.
So is it like coincidence that you became an engineering professor, or your love towards physics?
Yes, physics, and then it's automatically turned into engineering, and the education system is always the engineers should be good in maths and physics. So I was good at maths and physics, so then it's automatically lead to an engineering world of engineering. But yes, if not that, and then probably it's a physical science, and then and do a special in physics and be in that area.
So can I ask, when you were doing your A-levels, I'm sure you would have done maths, physics, chemistry,
and
higher maths.
No,
Pure
maths, and applied maths.
Pure maths, applied maths. Yeah. So did you have a plan that okay, this is what after my A-levels for my university, this is what I want to be doing. I want to be studying engineering. Did you have a plan like
that? Yes, I already thought about that, but to be frank and honest, I want to be a professor. It doesn't matter it's a medical field or engineering field or physical science or whichever. But then it's happened to be in an engineering field, and where You can do theoretical things as well as the application side of it. So that motivates me more into explore the application side, which has a solid theoretical background. So where I can innovate and identify new things. But if it is, say, purely physics or double maths type of work, and then it's mostly theoretical, and then that goes into application later on, but you can't see immediately that goes into application.
Thank you, Doctor, for that answer. Concrete, steel or timber? What's your favorite material to work with?
Of course, it's a concrete, and it's a versatile material compared to other two. And the way it's allow us to design the structures, and it can turn into different shapes. And say, for example, it can be bridge, it can be tunneling, it can be any type of infrastructure or the architectural element, which can be more complex. So the concrete is a very versatile material compared to many other, and widely used construction material. And the way it's evolved from the conventional concrete, which was used for a long time, to current technologies like fiber reinforced concrete and ultra high performance concrete and self-cleaning concrete, and so many other things like geopolymer additives comes into low carbon concrete and all. It evolves a lot in many other ways. So the concrete is the most important and widely used construction material currently, and it's give more freedom for you to work in different types and different varieties and different applications. So that's the passionate things for me to work on and research on concrete, and I always interested in working with concrete.
So what you're saying is, Doctor, the concrete that we are using is different to the concrete that was used 10-20 years ago?
No, still we are using the similar type of conventional concretes. That's the normal one, but then depending on the application, the type of concrete is changed. That means if you have a crack control and then high ductile concretes, and then we probably go with steel fiber reinforced concrete. And then if we want to design a structure which has to carry a large amount of loading and different nature of loading and high-rise building and all, probably we might go for high performance concrete or ultra high performance concrete, which can go up to more than 100 MPa strength. So, but the normal conventional concrete we used to have in the order of 25, 30, 40 MPa, but it can go the high performance concrete can go up more than 100 MPa.
What is MPa, Doctor?
It's the megapascal, the strength level, the strength, very high strength. So it's depending if it's the bridges or the high-rise building or high scrapers and all. So we change the formulation. So that's the beauty of concrete, and it's allow us to change change the strength and durability performance and all these different serviceability, not the serviceability performance, but durability and strength performance, and depending on the performance requirement, you can decide which type of concrete to be used and how you are going to use. It's all within our hands, and we can modify it depending on the...
So concrete is, I mean, the concrete that we see is not the concrete in all structures. So based on the structure,
the performance requirements of the structure, and all determines what type of concrete to be used.
Because that's what sort of holds everything together. Because, I mean, we are staying in a region where we want to build the biggest, the tallest, the largest, the longest, everything, right? So
I think it's probably they use the ultra high performance concrete and fiber reinforced concrete, but it's purely depend on what type of application we are looking for.
What's one gadget or tool you can't live without?
At the moment, I can say the mobile phone. Everyone want it, and if the internet is off for half an hour, and everyone started to go mad basically, and it's like yes.
So it's safe to say your mobile with a good internet connection.
Yes, and also and the mobile phones nowadays, the smartphones, has most of the features, and you have a calculator into that, and then you have all the apps you want. And sometimes even the design tools are becoming an app, and then you can download and then do it. It's like a small computer. So I think without that, it's been difficult to survive nowadays. So
if I'm to ask you, if you are to choose a mobile as an engineer, what do you check?
for me, I know, okay, if I want the quick calculations, of course I use the mobile phone, and you won't carry the calculator all the time, and so that. And then if I want to check some of the information or equation which I need it for the quick calculations, and then you can check, go to the internet and then check it and get it done. So I think that's yeah, of course we can't do the engineering measurements using that at the moment, but in the future it might evolve to that level even. You never know, and the pressure monitoring and all coming in. And the same way, maybe you can map even the crack in the concrete. And
so there are no such software tools made yet.
No, there are specific equipments to map the cracks. That's all. But then you have to carry those. But if that's built into phone, and then you go and take a photo, but there are ways. And if you have a photo taken and then use the photos, and there are AI-based tool which can tell you what's the crack width and what's the extent of the crack and all. So the image processing basically. So if that's becoming an app, the mobile app, then it's easy to do. Probably it's already there.
So what you're saying is there are tools and softwares that are used to check structural integrities of
Yes.
The biggest engineering fail you've ever seen?
So one of the recent failures, a striking failure happened on the bridge is the Morante Bridge in Genova. That's the cable stay bridge, which has collapsed and several fatalities has been reported. It's happened in 2018. So this has been designed properly and then analyzed properly, and the design phase and the construction phase is all okay. But the failures mainly happen because everyone thinks if you do a safer design, the structure will last for the design life. But more than that, for the infrastructure side of it, the monitoring of the structures, how it's performing over the years, and if is there any deterioration happening in the structure, or any type of failures or any type of damages happening in the structure, it's very important. Especially even in real-time monitoring would be much better. So this failures mainly happen because there are not enough routine maintenance process implemented properly. So that's lead to a catastrophic failure of the bridge, and it causes several fatalities, and that teaches the importance of after design or the post design and construction, how the structure should be monitored, and how important that the condition monitoring or the routine maintenance of constructed infrastructures. It's important, and especially it's very much important nowadays as a change of climatic conditions and the impact of climate change and all. It's also make the structural performance worse. So it's need to be properly monitored over the year. So that's one of the failures quickly came into my mind.
Oh, so what I'm trying to understand this. So when they built the structure, it was well in order as a handover
Yes, the
project.
performance probably up to the level, the desired level they want.
But after, when it came to operation only,
during operation, the due to the various deterioration process and the damages happening on the structural material, so the design level started to drop. The whatever the performance is intended during the design or achieved in the design is drops over the year. So this need to be monitored. That's the routine practice. All infrastructures is properly monitored and maintained to keep up the same level as the performance is expected in the during the design phase. But if that's dropping, then we do a rehabilitation for that structure to bring it back to the original level or whichever the desired level for that current state. If that's not properly done, then it's started to deteriorate over the time. And when the structure deteriorates too much, so then your loading goes up beyond the capacity of the structure, then that's lead to the failure. So we should know where we are operating currently and what's the deterioration process and where it's going to be in after 10 years probably or 20 years. Then we should check is that level is adequate enough or not, and then we plan for the rehabilitation.
So that's a very interesting answer, Doctor. That prompts me a follow-up question.
Yeah.
Whose role is this? I mean, is it the structural engineer's role or the civil engineer's role or the material engineer's role? Whose role is this to make sure that the aftercare, servicing, maintenance of a structure is looked after once it's handed over to a client?
So that's the good question. So nowadays the engineering is multidisciplinary. So it's not in one discipline, and because of various invention and innovation happen in the material side and construction technology side, and then how we are going to monitor over the time, and then say that's called structural integrity monitoring group. So they use different technologies and different approaches. So it's like a team effect. So in the design phase, the structural design engineers who design and then select the material which is suitable for this structure to perform in an adequate level. And then once that happens, and then the material engineers, they confirm that the material is up to the level and they follow the standards and all. And so the material will be supplied and the construction happen. The construction quality need to be monitored, and so it's another other things need to be checked, and that time is most of the failures and most of the issues happen in the construction time compared to other two phases. And sometimes the rebar missing, and the design engineer might specify, say, this many number of bars should be on this element. But then in the construction side, and the construction workers might do less or more bar, it depends. So the construction issues is a big one. So that need to be properly documented and monitored during the construction time. Once it's handed over, as you are, it's the client, and then they have to start monitoring the structure. So that's where the structural integrity or the condition monitoring group comes into for larger infrastructure. Their role is placed, and they have to use proper technology and techniques to monitor. And then once the data is collected during the monitoring, this need to be analyzed properly again by the structural engineer, that it has a performance level matches with the design level. So if that's not the case, so it's like a team effort, and it's not biased to one type of group or one team to blame on. So these all protocols should be right. So that's where I can see even in the Qatar they have developed, and most of the infrastructures are maybe new, and it hasn't reached the design life of the structure. Is normally we place it 50 years or 100 years design life. It's depending on type of structures. If it is a residential building, probably is 50 years. But if it is bridges and then large infrastructures, go beyond 100 years or 100 years. So probably these whatever the large structures in Qatar at this stage, it hasn't reached to the design life. So probably it's okay at the moment, but due to various environmental conditions, it can deteriorate faster than expected in the design time. So anyhow, it needs to be monitored. But the biggest problem nowadays is there are so many infrastructures which we use in the daily life. It's almost reached the design life or already exceeded the design life. So what will happen, and that time you have to replace or rehabilitate the asset. It's a massive economic pressure for the country or the authorities.
Yeah.
So that's where if you have a early detection properly done, maybe your rehabilitation approaches or the techniques may be easier than if you detect at the last and then you have...
When it's too late.
Too late to do.
Yeah. So my question is, as a student, if I'm a student who wants to learn civil engineering, so is it that, I mean, all these engineers that you told, the structural to the material to the product engineers to all the engineers that you mentioned, are we all going to learn in the same classroom, or is it different programs, or is it that in the same program that whatever I'm studying, I'll be basically specializing on one area? How that works?
So in general term, they are not going to study the same thing, but there are few areas is common for both, or few. So they have to specialize on those, but then they specialize more on, say, if it is a material engineer, you try to specialize more on the material side of it. And if it is a structural engineer, you trying to specialize on structural design, how to analyze and how to design the structures, and which are the new technologies or the softwares available for them to analyze the structures, which may not be very much useful for the material. But then when it comes to build the infrastructure, say for example bridges, and then all should come into one table. And it's the skill, the teamwork is very much important in the actual design or the industry practice. So that's where the nowadays student has to learn and how to work in a team and how to make a decision, appropriate decision, and the right time to do right things.
So engineering is not only about building things, but looking after things that is already built also.
Yes, and also engineering is not only like learning the techniques and calculation methods and design methods, and it's more than that nowadays. It's like trying to work collaboratively and then decision making and reduce the risk. And then the other aspect is that everywhere the government and policymakers trying to push the sustainability aspect of it. So you have to understand how you can bring this sustainable aspect into your design, and say for example that alternative cementitious material to reduce the carbon emission. And then if it is end of life, and most importantly nowadays if the infrastructure come to an end, and what's the approach for the end of the life, and what you are going to do, and just demolish and leave it, and it's all the waste going into landfill, or what you are going to do, recycle and reuse it. So it's all need to be answered. So the engineer is not only good at computation, it's much more beyond
much
that.
bigger. Yeah, very interesting. Yeah, I think I know the answer for the next question, but I'd like to hear from you. Favorite city for civil engineering inspiration?
I'm slightly biased to this, and again I'm going back to Italy. And Rome, because it has ancient heritage, and it shows us the marvelous engineering things has been done by Romans back in a long time back in 75 80s. Yes, last centuries mainly say. So it's the place you can see different type of structures and large structures, and the way Romans thought through the modern engineering practice and how they brought it or use it on those times. Say even if I go back again to the Colosseum can, at the current standard level, it can accommodate 50,000 spectators. 50,000 spectators. But those days, it's normally documented is 87,000 spectators. It can accommodate, because now maybe
it was built for 87,000.
87,000. That's what is documented. Okay, so to do that, and then they have thought through even the crowd management techniques we use now. It has the Colosseum itself. It has 80 entry points to go inside. So that shows, and so how Roman thought through the crowd management even in ancient times. So which we still admire, and then they have gone through that detail to design. So each and every location in Rome, particularly for me, it teaches something on engineering marvelous which Roman has done it in the past.
So can I also be a little biased and ask, okay, so that's on ancient terms.
Yeah.
What's your modern day inspiration for engineers, civil engineering marvels?
So now, if you ask me now, and the city you would like to see, or I would like to see, and then see the biggest skyscrapers and all is of course the US. And there are concrete structures that have been built, and especially in California, and structures has been built to resist the earthquake loading. And then so that's another complication comes in normal compared to the normal design, where we normally consider the static loads and the wind loads. But if you go to seismic zone, and then you just you can't design only with the static loads and the wind loads, and you have to consider the seismic load, which is unpredictable. The magnitude of the earthquakes and the duration of earthquakes and all. So, and the dynamic natures, when you go high-rise building and all, the dynamic characteristic of the building is very complex to analyze. So whatever has been happening in US and the development in concrete structures or any other structure, steel structure, is another place you have learned the modern engineering. And then if you go to Australia, you will learn all about the sustainable construction materials and what has been happened with, especially in geopolymer concretes, and the techniques they have used to monitor the advanced techniques to monitor the existing structures. That's another part you can learn from there, the sustainability aspect and how they bring the sustainable aspect into each and every design, especially in infrastructure design, which has been funded by governments and all. But then there are so many other places, even in Qatar, there are so many different architecturally aesthetics building, and it has been built in concrete and steel and all composite structures. So everywhere you can learn new things, and each and every large structures especially use at least one or two or many new innovative techniques, or the design methods or construction methods and all. So that's
Earthquakes or skyscrapers? Which challenge excites you more?
I think earthquake, because it's the unpredictable nature of earthquake. It's very difficult for engineers to design and control the behavior of the structure, and then that's create more issues on the way we analyze the structure. And if the structure get complex, and the dynamic characteristic also go complex, and so in that sense, the earthquake is excite more compared to skyscrapers. But saying that, of course, in the design of skyscrapers, again, you have to consider all different type of loading, especially earthquake loadings, depending on the locations, and so that's also controls. So saying that I think the earthquake is the most exciting thing.
That prompts me to ask you, I mean, when I saw your profile, I saw you have done a bachelor's in civil engineering, you went to do a master's in earthquake engineering, and your PhD is also in earthquake engineering.
That's correct, yeah.
What made you, I mean, I think in my life, I mean, you're the first person I've met who has done a PhD in earthquake engineering.
Yes, that's because I just basically got my bachelor degree from Sri Lanka, so it's not seismically active zone. So we won't learn much about structural dynamics and how the structures behave during the dynamic loading, but we learn well enough on the static loadings and how the structures behave on static and wind load, but not much on the seismic load or the dynamic loads, highly complex dynamic loading cases. So that's excite me to go and learn more on the dynamic nature of structures and how it's going to behave. That's why I just wanted to do my high studies in earthquake engineering, especially looking into dynamic characteristics of the structures. So that's why I went to do the masters, and then I continue the PhD also in earthquake engineering.
What's your guilty pleasure outside of academia?
Okay. I like to travel.
Okay.
And not just to travel, and that's giving me understanding the difference, or just to see the different cities and countries. But I like to try out the food.
Okay.
So I'm a bit of foodie, and in that sense, so I like to try out foods, and so the travel and the food goes hand on hand on that sense. So I travel a lot and then explore different type of cuisines and their culture, because always the culture and flavor goes well, and so you can understand how they behave and all. So it's
and then structures also, right? I mean, from Japan.
yes, different places. Of course, you will see how
Yes.
the engineering side of the cities and what happened and what's available. So it's like outside engineering, and then I like to try out different cuisines and the food. And so since I travel a lot, and then it works well for me.
So how often you travel?
If you ask me, in a year I might go out from Melbourne at least 4 or 5 times outside Australia. Yeah.
Okay. Who's the most underrated inventor or engineer in history?
I would say the underrated one is Nikola Tesla.
Nikola Tesla.
Yes, it's for his invention in electrical field and electrical engineering and wireless communication. And on his time, it may be mostly underrated, and now everyone using his invention. But I feel like he's mostly underrated at that time. But his inventions are marvelous, and its applications in every field and more or less. And otherwise, we won't have even the wireless communication nowadays.
Yeah.
So
I think most of us we knew Nikola Tesla after Tesla came into the
yes, Tesla came into
existence.
action,
Only
and
we
then,
knew there was
yes,
Nikola Tesla also.
yes.
Yeah. So complete this sentence for me, Doctor. Engineering is the art
of creating new structures and facilities for improve the people's lives.
just like that. So engineering is the art of creating new structures to improve people's life.
Yes, structures or any element that can improve the life of the people or elevate the current life of the people.
So engineers have been elevating our lives by
That's what I believe that normally happen, because if I put it in another word, anyone can dream, but engineers can make it happen. So you can dream, I want the house like this, I want this and I want that, but I want bridge and maybe I want tunnel over here and all. So the engineers can make it that to happen, I believe. So in that case, it's basically elevating your current expectation from one level to another one, or that's basically elevate your lifestyle and all sort of things.
All right, so with that, anyone can dream, but engineers will make it happen. See you on the other side.
Thank you.
Right, entering stage 2 of the conversation, doctors. You worked in Italy, the Netherlands, Australia, and in Sri Lanka. How has your global experience shaped your perspective on education and engineering?
That's working in different countries and working in different teams. It's provide you different aspect of how the work style changes between or among the countries, and how they work and how they think and approach the same problem in different ways sometimes. So that's the good lesson for us to learn, and that good opportunity is happened for me, and then to work on the various places, and that's improve and my knowledge on understanding the different cultural perspective of say for example in the civil engineering side, when you design the structures, how you consider their cultural aspect into the design, and then how you execute them, and what's the process to follow and all. Say for example, if you take Italy, and then that's the culturally rich heritage city, and if you come to the Netherlands, and they are good at doing water management, so it's a different aspect to that. And so whatever you design, and you have to of course consider how you are going to manage those the inflow of water or any issues with water management systems. And then if you go to Australia, and then you have to consider all these new approaches and innovative techniques for construction practice. So that's the good experience for me, and learning from different places and different people. and their approaches to the same problem or different problem. And so those ideas I can use into educate my students, and that's give a different experience to them also. And they can understand how this one problem can be handled in different ways, and that's help me to design the student projects well. And of course it's a much better experience for students, and of course for me to work in different places.
Experience and exposure matters.
Yes.
Your work includes earthquake resistant structures and pipeline failure prevention. What inspired you to get into this kind of high impact real world engineering?
I would say I'm a bit lucky to get those opportunities, and say this is actually happened. I worked in different places with the different people, and each will work on different aspect of infrastructures or any type of civil engineering problem. So since I was changing or moving places and explore new opportunities, and that's where I got his chances to work in different areas, and that's for me bring a broader picture of handling civil engineering problem, and see the broader view of and how to manage various problem with complex infrastructure interactions, say for example. So I believe that experience is more valuable for me. And then the one thing is I always wanted to do, and I still doing, and I never limit myself. And if there's an opportunity to learn new different structures or different areas in civil engineering, I'm always trying to explore and then trying to understand what's there. So that's why I think I'm not restricted myself in the beginning to contain into one area. So this actually, the earthquake one is I did it up to the PhD, the postgraduate study, and then I moved to Australia, and where the seismic activities is very low. There's not much work on seismic side. So soon after my PhD, I moved to Australia, and then I started working on pipeline. That's why I got into pipeline. And then I started understanding what's happening on pipeline industry and where the problems are and all. And so I worked on water, oil and gas pipeline. So then I started exploring on concrete 3D printing. So it's like it's ever evolving and trying to understand the different aspect of civil engineering.
Keep an open mind and learn something new every day.
Nowadays, I think that's important. I would like to emphasize for the new generation engineers. It's so much of information and so much of tools and opportunities are there. So it's always you have to be open and open to adapt. But then you should know which one to adapt and which one not, because so much in AI and the internet evolves, and then you have access to so many information.
So much of noise.
Noise, and you have to really identify which one is important. And that's where you have to improve your knowledge. And the universities like Barzan or Swinburne, any university education, you should learn which one to look for and which one you shouldn't spend time more, because there's so much of noise, as we mentioned.
Let's talk about engineering resilience. In a world facing climate events, disasters, and infrastructure challenges, why is this more important than ever?
So engineering resilience is not an option anymore. It's very important to consider nowadays. And it's part of the design process because of climate changes and urbanizations and so many different impact, social impact and economic impact into these infrastructure design process. So the infrastructure resilience is an important phenomenon. We have to consider in each of the design process. That means even if the structure is or the infrastructure is subjected to earthquake loading or any climate loading, and if it's get damaged, and we normally prefer that to recover faster to serve the community back. So the resilience is very important nowadays, and it's not the choice anymore. So when you design, when you take decisions, and when you take any constructions, processes, and every process and every step, and the resilience is important, I believe. I would like to add one more thing from the resilience, and the redundancy is also important. So now these any structural design process, and they're trying to improve the redundancy and the resilience. That means if one of the member fails, and then the load path changes, and then which member is going to carry that load, even though one is missing. So that's called redundancy. So if the redundancy is not there, and then it's going to fail anyhow. So that's on the new structures. But if you go into the old structures, which has been already designed and serving us, and that's need to be strengthened to at least accommodate the redundancy or the improve the resilience of structure for any future loading coming into that. So there are new technologies to improve or rehabilitate or particularly strengthen the structures for any future loading. If that's already underperforming than expected. And so, but then again, it's going back how you are going to assess. And so assessment is very important, and that's where then you can plan for your rehabilitation plan for those type of structures.
You work with everyone from state governments to the European Union. What do those partnerships teach students about the real role of an engineer?
I think, as I explained before, that the engineering work is nowadays a teamwork. So there are different stream of engineering teams associated with one particular project. Not only that, and then the other part is like environmental aspect into that design, and the policymakers comes into play, and the stakeholders, and all these aspects need to be considered when you implement the project in the beginning stage of the project planning stage and the construction stage. All these guys should be engaged. So that means you are dealing with the people who are not non-engineered people, and so you should learn how you are going to communicate with them and how you are going to transfer your ideas and the decision to them, and explain them and what's going to happen if they have a different view of this particular project, and you have to address those issues. So working with various authorities, especially the government bodies, you can understand where the policies are and how you can satisfy those policies, whatever the project you are trying to implement. And then that's basically give a knowledge on how the whole system operates. And then that's also improve my knowledge on to explain the students and how to work in a team and how to communicate, how to convince. And so it's not only the technical skill of the students, and it's various aspects associated nowadays. It's not you just design and computational side of it and then leave it, okay, it's all done. That's not anymore.
So as an engineer, you won't only be working with materials, but you work with a lot of policies and people also.
It's a sustainability policies and environmental policies, and also Qatar has that national vision for 2030 that basically covers the humanity and economy and all sort of things. So you have to understand the cultural perspective of the country or the city, and you have to understand the economic status of that. And you can bring some normal countries massive skyscrapers, and they can't build it that one. So it's so many aspects to one project.
So you're so deeply involved in advanced sensor tech and digital modeling. What do future engineers need to know about working at the intersection of tech and infrastructure?
So tech and infrastructure. It's nowadays is the back to back. That means the technology development is rapidly evolving in the current years, and new technologies are coming. And I believe that any infrastructure project or anyone working on infrastructure areas, they should update their knowledge into the new technologies on, say, for example, in any new project, and there are countries, they mandate the BIM modeling, the building information modeling techniques. So that means everything is documented in a digital framework. from the design to the construction phase to the post-construction assessment. So everything is nowadays is digitized. So it's not mostly a paper, the hard copy based approach which the engineers used to be in the last decades. But now it's all digitized, and I believe that the future students or the engineers or the next generation, they should improve their knowledge into fundamentals as well as the tech side of it. So which that's the main reason that Swinburne always pitch it like technology and people together to make the world better. So I think the digitization is it's important for, especially in infrastructure projects. And I believe that UK and all is already mandate the BIM. Without BIM, any project won't be executed. So the BIM is building information modeling. That's mandate. I think Qatar definitely has done that one. And there are a few countries is mandate any design or any infrastructure project, the BIM should be implemented. That means everything is digitized. So anyone can see anytime what's the structure and what's the information and what's the real-time monitoring of the structures going on.
I mean, that sort of prompts me even for civil engineering also. Cybersecurity is going to be important since everything is going to be in digital.
Yes, that's the next phase of it. Then if you make it everything digital, and then the cybersecurity comes. Yes.
Yeah. Interesting. Yeah, I think what better way to end the segment? People and technology together to build a better world. So with that, we conclude the second segment. I'll see you on the other side with the third one.
Okay.
I think it's a very interesting conversation we are having, Doctor. I mean, talking to you, even I'm interested now to explore on civil engineering because all this time I was thinking civil engineering is about more on calculations, a lot of mathematics, a lot of physics. Talking to you, it sounds really interesting. A lot of experiences, a lot of explorations, a lot of practicals, hands-on. And civil engineering is not only about building new things, I think it's also about taking care of what's already being built. With that, let's go into the third and the final segment where we talk about how we can assist or help students, parents who are looking at engineering, specifically in civil, how we can guide them. Right. To a student who's great at math and science, or who is average at math and science, but unsure about civil engineering, what would you say?
If somebody is interested on maths and science or physics, it's civil engineering or engineering in general is could be a good fit for them. But saying that, it's not only about computation, especially civil engineering. It's not about only computing things. But the civil engineering is much beyond the computation. It's to think about the risk associated with the building a structure, and then how that's going to affect the performance of the structures or the society, and then how the impact of building something in an open space, and what's the impact comes to the nature due to that building process. And all has to be comes under decision making and planning and all. So it's not about the computation. It's all the various aspects involved into preparing that, preparing the design and building something. So why we are building is to improve or elevate the people, how they move and connect and all that, facilitate those people lifestyle expectation. So that's what we are doing for. But then civil engineers is normally everyone thinks, and so they design, they build. But civil engineering is not about designing and building only. It's you may end up doing various things. That means one day you might work on building a normal concrete structure, but the next day you might work on earthquake resistant structures, and some other day you have to work on the irrigation system, and then environmental policy makings and all. So it's it brings, and the civil engineering is broad, and it brings various aspects and various discipline within its own civil engineering umbrella. So it's give more opportunities, and basically every day you will have new problem and new things to deal with it. So if you are not unsure what to do, it's okay, and you can go and talk to people and talk to engineers and then the industries, and trying to understand the process and what they are doing and how they are doing, and then you can make up the decision based on that. But it's the civil engineering, it's not only just what you see as just the success building on outside and that's okay, civil engineering work is happening. That's not the case. It's much beyond that that what you see.
And if I'm to ask you, Doctor, if I chose to study civil engineering at Barzan or with Swinburne, will I be doing more theory or more practicals, or what's the balance?
It's the good thing. So especially that as you know, in Swinburne or Barzan, what we are trying to do, and there's the aspect of work integrated learning associated with each of the courses and the deliveries. And what we are doing on work integrated learning is we are trying to embed the industry-based project into our curriculum. So at least the students get the exposure from the beginning, that means first year to the final year. They will always engage with the industry in number of units, or maybe at least one unit, and trying to understand different aspect of the civil engineering process involved or used in the industries to make decision and build structures and planning structures. So the work integrated learning is the DNA of Swinburne, and that's what we are trying to implement in Barzan. So the students exposed to industry practice, and they learn the new techniques, and they can be placed in the industry. So once they finish the courses, they are job ready graduate than the normal classical way of you learn all the theories and then you go and learn how the industry works. But here the advantage is the students from the beginning itself, they have a option to engage with the industry practice, and then that will be scaffolded all the way to the end, and so they are basically job ready after graduation.
Very interesting. Engineering is becoming more multidisciplinary. How will that change the kind of degree students should be looking?
So you are right. It's multidisciplinary, and also it brings various aspects and technology to that. So I believe that the students nowadays should be open to learn the fundamentals of civil engineering together with say different technology, not only technologies, and the data science, and the AI is coming into the mainstream decision making process. So how to handle with those things, and different sources of information or incomplete information, and how you are going to manage and making decisions. So it's much more challenging for the students to learn various things and then embed those and consider those into their future applications and when they practice in the industry. So they should be open to learn various discipline and to embed into some of the future works they are going to lead.
Good. So to parents, what skills should they be encouraging beyond just academic performance if their child is considering engineering?
So the parents should encourage them to be curious and innovate new things, and then explore new things, and that's where the actual innovation comes. The curiosity is lead to an exploration, and the exploration comes into innovation. And so they have to encourage the kids to be curious about things. If the kid is curious to something, and then support them to evolve on that, and then explore onto those ideas, and then find out new things. And also they can give an opportunity for them to access different technologies and different way of thinking, and then nowadays the information is everywhere, so we had to filter them as a parents and then provide them the right guidance on. It's a difficult task, of course, and what to look for and what to engage for. And that's where then these the kids or the students will learn how they can manage their time efficiently, and what action need to be taken to be successful engineers or lead the next generation.
Yeah, I mean, so what I gather from what you're saying is, Doctor, you're not only looking at a child who is acing his exams, but you're looking at an all-rounder, who will be good at their exams, good in their subject knowledge, but will also have a lot of extracurricular work. They've exposed themselves to, like what you said, on innovation, leadership, all sorts of different things. So that will make them a good professional.
That's correct.
Right.
And it's not only about writing exams and getting high grade. That's probably okay in the past few decades, but now the world is moving in a different direction, and different ways you can do those things without putting much effort into so the information is in your hand. So now the main skill I believe that to be developed is the decision making, what to look for, and so which way is efficient for me to do things. So it's a completely different paradigm we are in, and to look for and work for, and so the mindset should change. And it's an interesting era. As a changeover happens, then everyone should adapt to that. And so I think future engineering is not about theory or writing exams. It's much more than that. To develop the skills on how to deal with the digital technologies and how to work with large data sets and the informations, and what to look for, and how to accommodate others' views, and making decisions benefit for everyone. And so that's basically the teamwork, and so it's, and policy making and adaptability is another thing. So it's much more than the classical way of learning in the past.
If you could design an off-the-syllabus course for future engineers, what would it be and why?
I think I would say, even for me, it's like the course I would like to design and name it as Engineering in Uncertainty and Beyond the Blueprint. Think beyond the blueprint. So that may be a better word. So it's like the engineering in uncertainty and think beyond the blueprint. So in that that type of course or the modules, or whichever the way you want to call it. So I would like to cover the skill of decision making, risk reduction of future designs or any design, and then environmental aspect to that, and the policy making, and all these different themes should be embedded, and then also, of course, integrating digital or the data science and AI, and so all these or optimization things, all these different themes integrated together to make a better solution, which will see in the larger picture of multiple options, and then converge into an optimum solution which benefits at least everyone, which may not be possible, at least most of us. And then we will be building a better world. And because we have so much of information already available, and we have to use them to make a better decision, which will lead, I believe, that the better world in the future.
And I think this could be across the board to any discipline. I mean, times of uncertainty, think beyond the blueprint. I think this can apply to any discipline that you're going to be in, right?
Yes.
Whether it's engineering, whether it's computing, whether it's business or anything else, I think this makes perfect sense, especially on the given circumstances that we are living in.
That's I believe so. Yeah.
The last one for you, Doctor, for the day. in 2035, the best engineers will be those who...
So I think I have answered for most of it for this part, and I think
Let's say if you have to summarize.
Yes, and I
It in
think
few words.
the engineer who can integrate various skills from fundamentals to digital and data science to all, and then make decision making and make a better solutions or the better outcome to the society, who are the winners of 2030 vision. I think that's in line with the Qatar thing, and I have read somewhere it says they want to have skilled laborers or the skilled employees. So that means that the employees or the laborers should be educated to the next level. So these, if you can integrate all of these, and then when the new technology comes, so the conventional practices might go away. So automatically these laborers should be educated to the next level. So that's satisfy the vision of not only Qatar, is most of the countries. That's the same vision they share. Though that will support that.
Thank you very much, Doctor. Thoroughly enjoyed the conversation. Hope you did so too.
Thank you for your time, and thanks as well.
Yes. That was Dr. Rajeev, a powerful reminder that engineering isn't just about calculations and construction. It's about carefully shaping the world we want to live in. From earthquake zones to smart cities, from foundational skills to frontier research. The future needs engineers who think globally, act ethically, and design with resilience in mind. If you are a student curious about civil engineering or a parent wondering if it's just the right path, remember, this field isn't just future-proof. It's future in building. If today's episode sparked new thoughts or direction, share it with someone who's ready to build their next step. And follow Off the Syllabus for more conversations that challenge, inspire, and empower. Until next time, keep learning, keep questioning, and keep building beyond the blueprint.